I'll preface this by saying I meant to cross off question 7. I thought I did, and somehow it snuck in there. For those of you that take in physics, this is a very similar question to one that I'm sure you've seen before. For those of you that haven't taken physics, you have no idea what's going on. I might as well talk about it since it's here. This is total and complete bonus. This was not intended to be as part of this unit for the time being. So, looking at 7 right now. To avoid the sand trap, a golfer hits a golf ball such that its height is modeled by this equation. I want you to think about golf ball and the heights, and you've got that downward facing parabola. That's confirmed because our A value is negative. A negative A means the side parabola we are opening down. Now it says, when does the ball hit the ground? Well, guess what? What's a fancy word for these points where it hits the ground? Well, given the context of hitting the ground, they're asking for the values that are x-intercepts. So if I take my equation, negative 16 t squared plus 80t equal to 0, and I need to factor this, well, remember, factoring 101, your first bet is to pull out a GCF. So I'm going to pull out a negative 16t, and I'm left with t minus 5 is equal to 0, which when this piece gets set equal to 0, I get t is 0, and when this piece gets set equal to 0, I get t is equal to 5. So when does the ball hit the ground? Well, I whack it at 0 seconds, and it lands at 5 seconds. Good to put the units on there since we've got the context for the situation. I guess technically I'm totally assuming seconds. If your golf ball's in the air for 5 minutes, you might be on some very strange planet. We are then asked to find the maximum height. Well, I want you to think about maximum height for a second and realize that that is a fancy way of saying find the vertex. And here's a trick for as we're finding that vertex. I want you to remember that that vertex must be halfway between my x-intercepts because my parabola is symmetrical. So if my parabola starts at time equals 0 and it lands at time equals 5, then when I look at that ordered pair for my vertex, my x-coordinate must be halfway between 0 and 5, or must be at 2.5. Now that I know it's at 2.5, all I have to do is take that 2.5 and plug it into my equation to find my height. So I'll put my 2.5 in for t. And I'm not gonna lie, I don't feel like doing that off the top of my head. So I'm gonna jump over to a calculator for a second. And I'm just going to use my computer. So I've got 2.5 squared. That's not right. Whoops. 2.5 squared times 16, make it negative. That's minus 100. That's convenient. It's almost like I wrote this problem intentionally. And then that 80 times 2.5. Well, that's not too bad because that's going to be 160 and 40. So that's 200. So minus 100 plus 200 plus 100. Wow, it's almost like I thought about it before I wrote this question. Anyways, we get a max height of 100. And I guess technically we don't know if that's feet, yards, inches, hopefully feet. If that's yards, again, that's kind of crazy high. And if that's inches, that's not terrible, but I don't know how it's only going 100 inches high and then staying in the air for 5 seconds. But yeah, so finally it says what domain makes sense given this context. And here's what I want you to think about. Think about the picture I drew. That picture makes sense. Whack the golf ball, it lands at 5 seconds. But I want you to think about taking this equation and plotting it on Desmos. That graph on Desmos does not know that you are hitting a golf ball. and it is going to graph the entire parabola. If you are whacking a golf ball, does it make sense for that golf ball to be hundreds of feet below the ground? Not so much. And so because of that, we would want to restrict the domain and restrict it from 0 is less than or equal to t is less than or equal to 5. Because for our context, that is the only space that makes sense for our graph.